So stereoisomers are arrangements of the same molecular compound and structural compound in different arrangements. So basically what this means is that if I have a 4-chain carbon, on this carbon there's always going to be 3 hydrogens and 1 carbon bound to it. This carbon is always going to have 1 hydrogen and 2 carbons. This carbon has also got 1 hydrogen and 2 carbons, and this carbon has got 1 carbon and 3 hydrogens. This is going to be the same no matter what I do to the actual carbon, or to the molecule. But what I can do is, because this is a alkene where it has a double bond, the double bond means that it can't really move and twist. So it's a very rigid bond, which means I can actually have 2 ways that these can be arranged. So that you notice that this carbon, it can be, because this can't move, this could be arranged one way and this could be arranged the other way. So what I have is I could either arrange it where those methyl groups are both on the same side of those carbons for both of them, or they could be on opposite sides of the carbon for both of them. So in this one, you can see that they are in opposite sides. So my first one, if I do it this way, so I've got my carbon on the top and my carbon on the bottom for this one, and we call that a trans configuration because they're on transverse sides. Whereas this configuration, where they're on the same side, both on the same side of the carbons, we call the cis configuration. So these are called geometric stereoisomers, and they only occur for alkenes. So our next type of stereoisomers are what we call enantiomers. And I always have difficulty saying that word. So what we've got here is a mirror image. So basically, if I look at this, if I imagine I've got a mirror down the middle, you can actually see that this is the opposite of that, this is the opposite of that, and this is the opposite of that. So if I was looking at that in a mirror, that would be its mirror reflection. So your hands are actually a good example of this sort of configuration, because if I put that on top, it's not the same, so I can't superimpose on top, but they are mirror images of each other. So if I look at it this way, the other way of representing it is remembering that anything that is solid is coming towards you, anything that is or going forward in the page, dashed lines means it's going back into the page, and this is on the same plane as the page. So this is this configuration. If I tried to make this with the fluorine on the same side, you can actually see that this is not the same molecule. So my bromine and my chlorine are now on opposite sides. So they aren't the actual same arrangement. They are slightly different because we are looking at things in 3D. So if you have a mirror image, then it is what we call an enantiomer. Okay? So we need to make sure we don't confuse that with some that aren't actually stereoisomers. So in this case, these look different. So this is 1,1-bromofluoroethane, and at the moment they're looking different. They look like they're different. So I've got a methyl group, and then I've got my hydrogen, my bromine, and my fluorine that are attached to the second carbon. So at the moment it looks different, but I've got to think about, this is 3D. So remembering when we're doing our numbering, we're starting at the 1. So if I just actually flipped this around this way, they now look identical. They are actually the same molecule. They are not isomers of each other. So you've got to think in 3D. If you looked at it from a different way, if you looked at it from as a pure flipping it around the other direction, would it actually be the same? And in this case, it is. So this is not an isomer. So make sure when you're looking at those 3D diagrams that you look at what happens if you just turn it around the other direction, flip it. Okay, so our last type of stereoisomer is what we call diastereoisomers. So diastereoisomers So I'm going to look at 2-bromo 4-chloropentane. So I've got 2 different configurations of it here. So this is our pentane, so 5 carbons. And it just means that it's on 2. So always starting with our 2 and then alphabetic order for the 2 halogens. So bromo comes before chloro, which is why it's on the 2. And then on the 4th one, we have the chloro. So you can see it here, and we can also see it here. So we have the 2. So we have our bromo and our chloro. So are these the same molecule like we had before, or are they different? So in this one, I've got the hydrogen coming towards me and the bromine going behind. The chlorine is going behind and the hydrogen is going forward. So I tip that slightly so you can see. On this one, the bromine is coming towards me and the hydrogen is behind. So here, whereas the chlorine, I just need to do this so that you can see, so just twist it around. So the chlorine is still going back and the hydrogen is still going forward. So if I try and do this as a mirror image, so try and do this as if it was a mirror, you can see that I've got my 2 bromines are definitely the mirror because I've got my bromine and my hydrogen. So this is definitely a mirror image. But in here, it's not a mirror image. So this is definitely not the same molecule. It is definitely a different arrangement. But it's not a pure mirror image because this one is not the mirror image. This is the same configuration as it was before. So when it's definitely not the same structural form, the same arrangement, we still call it a stereoisomer. But if it's not an exact mirror image, we then call it a diastereoisomer.